Good day, everyone. So, this is our lesson on analysis and interpretation of assessment results. It is expected that before this lesson, you are already familiar with the methods of test construction or the steps in test construction, and at the same time, you have taken already lessons on item analysis, which includes index of difficulty, index of discrimination, and of course, the measure of attractiveness of distractors in a multiple choice type of test. Now, of course, after giving the test or the assessment activity to your students, it will be expected for the teachers that they know how to organize the results of their assessment activities. They also know how to analyze and interpret those results in different ways or in a good way, such that these results will be used for sound decision making that will be helpful in increasing student learning and at the same time improving the totality of our teaching and learning process. So after an assessment activity, a teacher needs to organize his or her data in a way that can help him or her better visualize the overall performance of the class, especially when important decisions are to be made to improve the teaching and learning process and for better student achievement. Other school leaders or administrators also use these techniques in research, accreditation, and administrative decision-making situations. And one of the most common ways to do this is to use graphical presentations together with textual presentations and tabular presentations of data. If you will notice in different schools, they are using graphs or charts and tables in their bulletin boards to present educational data that are important characteristics of the school. Now, before you proceed with the different ways of presenting data, let us first have a review of what you know about the different levels of measurement. Now, this lesson was covered, I think, in your statistics and probability in senior high school and your mathematics in the modern world. That's your general mathematics subject in college. So this is a very important aspect because the level of measurement or the characteristic of the data that we will try to present, analyze, and interpret will depend on the level of its measurement. And if you are familiar with these terms, then that's good. If not, then this will be a chance for you to review again what are these levels of measurement. So we have here four levels of measurement. We have nominal, ordinal, interval, and ratio. So what are the differences among these four levels of measurement? Now, in most books, they treat nominal and ordinal data as qualitative data, while interval and ratio are under quantitative data. Now, what do these labels under each scale mean? It says here that nominal are named variables. So nominal variables or nominal data are simply about labels or names or characteristics of which no one is higher than the other. An example of this is sex, male and female. We cannot rank or we cannot order male and female from highest to lowest. We simply have male and female and they are of equal footing. Similar with ethnic affiliation, every ethnicity is not higher than the other, so they cannot be arranged in a particular order. Now, if these labels can be arranged into a particular order, such as increasing or decreasing, the data or the variable is now called as an ordinal data or an ordinal variable. So you will see there the clue ordinal. Okay, we have the word order. So for example is educational attainment. Okay, highest educational attainment. If we identify the different highest educational attainment of, for example, the teachers in a particular school, we can order or we can arrange their educational attainment, okay, according to a certain order. So from labels, an additional characteristic of ordinal data is rank or order. Now we have here the interval and ratio data. So interval and ratio data contains characteristics. They have labels also. They can be ordered also, but there is a difference between interval and ratio. Okay? Interval, additional characteristic is there is proportionate intervals between variables, meaning that the difference between two steps or between two quantitative data are the same. For example, temperature. Okay? The difference between 9 and 10 degrees is the same as the difference between 12 and 13 degrees. This is not applicable for ordinal because, for example, in highest educational attainment, there is no equal interval in between points or in between data. For example, from elementary to high school, okay, the interval there is different from high school to college, okay, or college to masters or masters to doctorate. The differences between points in an ordinal data are not equal, or the intervals between data are not equal. But for interval and ratio, the intervals between data are the same. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that. And both interval and ratio have that characteristics that they have equal intervals between points. The difference between interval and ratio is the existence of what we call as the absolute zero. Interval data has no absolute zero, okay? While ratio has absolute zero. Now, what do we mean by saying absolute zero? When we say absolute zero, okay, zero means nothing. Okay? Zero means nothing. For example, in interval, the temperature. Temperature is a very good example of interval data because temperature has no absolute zero. Now, zero in the temperature in Celsius scale, for example, okay, 0 in Celsius or 0 Celsius, 0 degrees Celsius means something. It does not mean that there is no temperature. But 0 degrees Celsius means the freezing point of water, or it means something. So in interval, 0 means something. But in ratio, 0 means nothing. An example of ratio is your number of partners. Okay? When you say 0 number of partner, there is no partner at all. It means the absence or nothing. If we say 0 number of students in the classroom, it means that there are no students in the classroom. Okay? That's the absolute zero. So here are other examples and descriptions of the different levels of measurement. So for nominal, it assigns responses or data to different categories. There is no numerical difference between categories. Examples are sex or gender, marital status, your residence or your address, your major or specialization, your social security number, your zip code, and even your student ID. Remember a while back that I mentioned nominal and ordinal are qualitative data, while interval and ratio are quantitative data. Now, look at the ID number. We know that an ID number is expressed in numbers, but it is considered as a qualitative data because your ID number is your label. For ordinal scale, this is set of categories also, but they are ordered from least to most or vice versa. We don't know the numerical distance from each category to the next, therefore, there is no equal interval. Examples are results in a pageant, military rank, your letter grades in class, if there are schools who are still using this, A+, A minus, degrees held or highest educational attainment, medical conditions such as satisfactory, serious, guarded, or critical, and rank order of your preferences. For example, for Ruffles, Doritos, Cheetos, and Fritos. For interval scale, these are scales with values already, and there is the same numerical distance between each value. This scale has an arbitrary 0 point, meaning there is no absolute zero. For example, is rating, for example, rating about the appealing factor of a cereal box, current temperature, and other many behavioral science questionnaires, and even IQ. Why is IQ under interval scale? Because it has no absolute zero. Because getting zero in an IQ test does not mean that you don't know anything. Getting zero in an IQ test means something. Even in your quizzes or in your examinations, if you got zero in a particular quiz or exam, that doesn't mean that you did not learn anything from the class or from the lesson. It means something. Okay? It means something about your performance, or maybe the questions given were not fit to what you know. Okay? So zero in the interval scale means something. While in ratio, there is a true, meaningful 0 point. For example, is weight, okay, number of times you return to a restaurant, amount of money, number of questions, and distance. Okay. So these are data under ratio scale. So we need to know these different scales of measurement or these different levels of measurement so that we can choose which presentation are we going to use in our assessment results. Are we going to use graphical presentation or textual presentation or tabular presentation? But in this lesson, I will focus on two presentations only. We have the graphical presentation of assessment results, and we have the tabular presentation of assessment results. Let's just start with the graphical presentation of assessment results. We first have here a graph which is about the learning styles of the students. So this is very important for teachers. This is a very important information that teachers should know. And this graph can give a good visualization what is the majority, okay, of the class, or what is the major characteristic of the class. So from this image, you can see that 65% are visual learners, and 30% are auditory learners, and 5% are kinesthetic learners. And by simply looking at it, we already know that the majority of the class are visual learners because it takes up most of the image. And how do we call this? We have our pie graph or pie chart. Okay, pie charts are best to use when you are trying to compare parts of a whole. Okay? So for population presentations or characteristic of a population, we can use the pie graph or pie chart. So we also have this, which you are very familiar with. We have the bar graph. Okay? So bar graphs are used to compare things between different groups or even to track changes over time. However, when trying to measure change over time, bar graphs are best when the changes are larger. Because these large changes are easily seen in bar graphs, and the changes can be easily compared from a year to another when we are using bar graph. But generally, bar graphs are used for comparing, okay? Comparing things. Like the given example, it compares the male and female composition from class 6 to class 10. And from the bars, we can easily see that for class 10, 9, 8, and 7, there are more males than females. And for class 6, there are more females than males. So as easy as that. And this is another way of using our bar graph. The previous example is a component bar graph because there are several components involved, number of students, the class, and then we also have the male and female. While this one is a simple bar graph only because there are only two variables involved. We have one grouping variable, which is the type of school supplies, and we also have the number of supplies. Now, you are also familiar with this one. So this one is a line graph, and it is used to track changes over short and even long periods of time to see the progress of a particular student or of a particular school or a division or even national performance in different assessments. So when smaller changes exist, line graphs are better to use than bar graphs. Line graphs can also be used to compare changes over the same period of time for more than one group. Meaning, your line graph can also have several lines on it. If you are comparing different groups of organizations or people or whatever you are trying to compare. So this one can show the trend. Okay? It can show the trend whether it is increasing or decreasing or whether there is a pattern on the behavior of a particular data or variable. So you are familiar with this because in many news, it is used to show the trend of a number of COVID positive cases and other variables important in our daily living. So where can teachers use this? Teachers can use this to monitor student progress over time. Is it developing or is the progress decreasing? For example, you are focusing on 5 students in your class because they need more attention than the other students. So you can track their progress using a line chart. And you can identify which of these 5 students have increasing performance and which of them have decreasing performance. So what is this example here? Okay, it says here global literacy statistics. And for many instances, this is preferred than other charts. For example, bar graph. This is preferred over bar graph because of its visualization. There is additional aesthetic aspect in it which draws the readers to understand the given information or the given data. And this is an example of what we call as a pictograph, or for others, they are calling it as pictogram. So you can use pictograph whenever you want to make simple data more visually interesting, more memorable, or more engaging. Now, each image stands for a certain number of things. And we can also use it to compare, just like this one, population of the UK. So there is a division of England, Scotland, Wales, and Northern Ireland. And of course, each image, as mentioned, stands for a certain number of things. For the first pictograph, one girl there stands for 10 students, while for the second pictograph, one man there stands for 1 million British people or Britons. So now, where can we find here the levels of measurement? Obviously, we can use pie graph for nominal or ordinal data, but for bar graph, we somehow use this for nominal also. For example, number of males and females, but we can also use it for interval and ratio data. But for line graph, they are more of quantitative, so we can use it for interval or ratio data. And for pictograph, we can use it for many other variables, okay, that we can identify. So another way of presenting data is tabular presentation. By the way, we only have 4 graphical presentations because these are the 4 most commonly used way of presenting assessment results, which are used by most teachers. And we also have here the tabular presentation. So as you can see, we have here race or ethnicity, and then we have the frequency or percentage. Now, from that tabular presentation, it can be coupled or it can be partnered with a graphical presentation, which is a bar graph. So here is another example of a tabular presentation of assessment results. So you can see here that there are score intervals from 96 to 100, 91 to 95. I guess this is very easy to interpret or to discuss the results because it's very obvious. Now, when do we use tabular presentations? So tabular or tables are useful in providing exact values, especially if the reader would want to see the exact values. And there are reports that it is better to be reported when we use exact values. And we can organize our data in tables if our readers would need the exact values for a particular set of data. And presenting complex results and an analysis of your findings. Because when you discuss, you will need numerical data, and so tables can be useful for that. So you have here an activity or an assignment to make. So the bar graph shows the data gathered from one school about their students' favorite after-school activities. So you can see in the bar graph the different after-school activities and the frequency count or the number of students who are doing each after-school activity. So your assignment will be, first, give a discussion of the results found on the bar graph. And second is to answer the question, how are this data useful for the teachers in that school? Or how can teachers in that school use the data about the students' favorite after-school activities? So that will be the end of this lesson on the analysis and interpretation of assessment results, focusing on graphical presentation and textual presentation of data.